Overview. The RJ stores its fuel in 3 tank areas: wing tanks, left and right, center tank, auxiliary tanks, also known as pannier tanks, to increase the fuel capacity if required by the customer. Fuel is transferred from the center and then the auxiliaries to the wing tanks and from there to the feed tanks. All fuel burned by the engines has to pass through the feed tanks. Under normal conditions, fuel is moved by jet pumps from the main fuel tanks to feed tanks. Each feed tank has an electric boost pump to supply its own engine and power the jet pumps. A single boost pump is capable of supplying all engines if the other boost pumps fail. If all the boost pumps fail, the jet pumps are powered by hydraulic fuel pumps, and the engines will suck fuel from the feed tanks. If the hydraulic pumps also fail, most of the fuel can still be fed to the engines by a combination of gravity feed and suction. The fuel tanks are a fixed capacity, but the weight of the fuel that can be carried varies with the specific gravity. The normal fuel system. Fuel is pumped to each engine by its own AC-powered boost pump through a non-return valve and a low-pressure valve. The left outer and right inner pumps are powered by AC1. The left inner and right outer pumps are powered by AC2. In an emergency, closure of the low-pressure valve is carried out mechanically by operation of the fire handle. The boost pumps are located in feed tanks in the outer part of each wing. The outer wing is used because it is the lowest part of the system and therefore the point to which fuel naturally flows under gravity. The inner feed tank supplies the inner engine. The left inner feed tank also supplies the fuel for the APU. Overflow from the inner feed tank maintains the outer feed tank full via a high-level weir or spillway. For this overflow to occur, the transfer system to the inner feed tank must be capable of exceeding the maximum demand from the engines. The outer feed tank supplies the outer engine. Outboard of the outer feed tank is a vent or surge tank that takes excess fuel in the event of overfilling or thermal expansion. This tank is vented to atmosphere via a stack pipe in the tank to an outlet under each wing called a NACA duct. With forward motion of the aircraft, air enters the stack pipe and pressurizes the surge tank to force fuel up to the vent line and back into the wing tank. The design of a Nacka duct creates a positive pressure. This makes it resistant to icing and allows the pressure to be felt in the fuel tanks. This aids gravity and suction feed in the event of loss of boost pumps. Wing tank transfer to the feed tanks. The boost pumps in the feed tanks also power associated jet pumps that transfer fuel. The inner jet pumps are necessary because at lower fuel states, gravity feed alone is insufficient to keep the feed tanks full at maximum demand from the engines. Three jet pumps in the inner feed tank transfer fuel from the main wing compartments. A fourth jet pump transfers fuel from within the tank to the boost pump compartment. More than one is necessary to ensure that supply exceeds demand, particularly when one boost pump is supplying all engines. The two jet pumps in the outer feed tank are necessary at low fuel states to transfer fuel from the lower parts of the tank to the boost pump compartment. Center tank transfer to the wing tanks. A jet pump, powered by the inner boost pump, transfers fuel from the center tank to its wing tank. If transfer fails on one side, the remaining jet pump will transfer fuel to its wing, except for 180 kilograms, 390 pounds, which will be unusable. Fuel reserves would now need to be increased by the 180 kilogram, 390 pounds, that is now trapped. Transfer is controlled by the center tank transfer switch. When the center tank transfer switch has been selected to auto, weight on wheel switches will allow the fuel to transfer automatically when the aircraft takes off. Auxiliary tank transfer to the wing tanks. Unlike the other tanks, transfer from the auxiliary tanks is by gravity feed, except for the last 95 kilograms, 209 pounds. Gravity feed will commence when center tank transfer is complete and the falling wing tank level uncovers a connecting vent line. The final 95 kilograms, 209 pounds, is transferred by another jet pump powered by the inner boost pump. How is fuel transferred from the center tank? Why are the inner feed tank jet pumps necessary in addition to boost pumps? System backups. In this section, We will look at the backups within the fuel system. Boost pump failure. Any boost pump is capable of supplying all 4 engines and the center tank transfer jet pumps. An adjacent engine is supplied through a common feed valve. Engines on the other side can be fed through the cross-feed valve to the inner engine and then common feed to the outer engine. Total boost pump failure. Aircraft at essential power level. If all the boost pumps fail due to a loss of engine and APU generators, 2 yellow hydraulic system standby pumps will automatically power the 4 jet pumps topping up the inner feed tank. The engine-driven fuel pumps will then suck fuel to the engine through the normal line. Although transfer from the center tank will be lost, the auxiliary tanks will transfer by gravity. Loss of boost and standby pumps. If the standby pumps also fail, fuel will still gravity feed to the inner feed tanks through flap valves. Fuel will then spill from the inner to the outer feed tanks, and the engines will suction feed. Gravity flow will keep the feed tanks full until about 2,000 kilograms, 4,400 pounds per side. From that point, the inner feed tank quantity will fall in line with the main wing tank, leading to isolation of the outer feed tank. This would eventually lead to flame out of the outer engine. If power to the boost pumps fails, how are the jet pumps powered? What will happen to the engines if the boost pumps and the hydraulic fuel pumps fail with a fuel load of 3,000 kilograms, 6,600 pounds, in each wing tank? Fuel contents indication. Fuel state can be checked and refueling carried out, provided batteries are fitted. They do not need to be switched on. The fuel state can be checked by pressing the fuel quantity push button on the flight deck. Fuel gauge failure. In the event of a fuel gauge failure, magnetic level indicators, MLIs, are used to check the fuel when the aircraft is on the ground. Each wing has 2 MLIs, one inboard for high fuel states, and one outboard for lower fuel states. 2 are required because the wing slopes down towards the tip, anhedral. If using an MLI, the aircraft's attitude must be noted, as this directly affects the fuel quantity registered. There is an inclinometer in the right-hand main landing gear bay that gives the information required to work out the correct fuel quantities. This procedure is given in the MOM Volume 1. External checks. On completion of this section, you will be able to carry out the external checks associated with the fuel system and be able to identify problems which require further investigation. Outside the aircraft, it is important to check the water drains, 5 on each wing, and surge tank vents are unblocked. There are no leaks from the fuel panels, 10 on each wing. The magnetic level indicators, MLIs, are secure, 2 on each wing. The refueling panel is secure. Refueling and defueling. In this section, we will look at the refueling and defueling procedures. Refueling. Pressure refueling is carried out at the single-point refuel panel. DC power for refueling is given when the master switch is selected on at the refueling panel. Before refueling commences, the earth-ground bonding must be connected. When the refuel panel door is open, or the master switch is on, the amber Refuel Selected light illuminates on the flight deck. During refueling, the crossfeed should be shut and all fuel pumps should be switched off. The left inner pump may be left on when the APU is in use. Use of the right inner pump would lead to overfueling of the right wing and spillage from the NACA duct. Attaching the tanker's hose to the refuel coupling starts the refueling procedure. The total fuel quantity required is dialed up on the pre-selector. The individual tank switches are 3-position: shut, pre-select and override. Normally, the switches should be placed to pre-select for the tanks being refueled. Wing tanks only are selected for fuel states up to 7,300 kilograms, 16,100 pounds, or 8,300 kilograms, 18,300 pounds, when auxiliary tanks are fitted. The valve position indicators read cross-hatched, unpowered, shut or open. With pre-select, the indicators should read open. Refueling can now start. Tanker pressure refueling up to 50 psi maximum can now be applied. Refueling stops automatically when the pre-selected fuel quantity is reached. The valve indicators read shut. Tank switches must now be placed to shut and the refuel master placed in the off position. Pre-select is used for fuel loads up to approximately 8,800 kilograms, 19,400 pounds, or 9,700 kilograms, 21,400 pounds, when auxiliary tanks are fitted. If a higher fuel load is set, the valves will shut automatically at the above quantities. Override must now be used, and the switches selected shut when the desired fuel load is reached. If the switches are not turned off manually, the high-level float switches will stop refueling when the tanks are full. This is indicated by the white full lights and shut. The hose can now be disconnected, the refueling cap replaced, the master switch selected off and the panel closed. How is the low-pressure fuel supply to the engine cut off in an emergency? What happens to fuel in the surge tank? Overwing, gravity, refuel. There are 3 filler caps for overwing gravity refueling of the 3 main tanks. The auxiliary tanks cannot be refueled from the overwing points. Defueling. AC power is required for defueling because the boost pumps are used. Initially, the procedures are the same as for refueling until the tanker is attached to the aircraft. The offload valve must be rotated to the 6 o'clock position after removing the mechanical balk. This connects the fuel feed line to the refuel-defuel line. If there is fuel in the center tank transfer must be open. The cross-feed and common feed valves should be opened and the boost pumps selected on. Tanker suction is applied to a maximum of -11 psi. When the correct load remains in the aircraft, tanker suction must be stopped. The boost pumps not in use are switched off. Then the cross-feed, common feed and center tank transfer are all selected shut. The tanker is now disconnected, the defuel valve reset, and the refuel panel door closed. The balk on the refuel panel will not allow the door to be closed unless the defuel valve has been correctly reset. Are the fuel boost pumps permitted to be on during refueling? What is the minimum power supply required for refueling? Pre-flight checks. In this section, we will work through the pre-flight normal operating procedures related to the fuel system. Before start. Once refueling has been completed, the fuel load from the gauges, fuel reserve from the flight plan, and engine fuel flow, 0 at this point, should be entered in the GNS. This enables the GNS to assist with fuel planning during flight. Then the 4 feed tank gauges are checked to ensure that they indicate full. The feed low level annunciators should be out. The aux tank not empty annunciators are checked. They should be lit if there is fuel in the auxiliary tanks. All other annunciators should be out. The center tank transfer switch is selected to auto if there is fuel in the center tank, otherwise it is shut. The cross-feed should be shut. The standby pumps should be at norm, and the common feeds should be shut. When the boost pumps are selected on, a check is made to ensure that the MWS fuel low pressure annunciators go out. The fuel contents are then checked to ensure they are correct, balanced, and agree with the technical log. If the APU is running, expect that the left wing contents will reduce at approximately 80 kilograms, 180 pounds, per hour. If full fuel has been selected, the indications will be with auxiliary tanks, without auxiliary tanks. The fuel used must be reset to 0. Complete the following 11 checks. On the GNS, enter a fuel load of 5,000, fuel reserve of 2,000, and enter the fuel flow of 0. Check that the 4 feed tank gauges indicate full and that the feed low-level annunciators are out. If auxiliary tanks are fitted, check that the auxiliary tank not empty annunciators are lit. Check that all other annunciators are out. Check that the center tank transfer switch is in the appropriate position for 5,000 kilograms, 11,000 pounds. Check that the cross feed switch is shut. Check that the standby pumps are set to norm. Check that the common feeds are set to shut. Set all boost pump switches to on and check that the MWS fuel low pressure annunciators are out. Check that the fuel contents are correct, balanced, and agree with the technical log. Set the fuel used to 0. In the air. When the aircraft takes off, fuel automatically transfers from the center tank to wing tanks. If the center tank is being used, a check is made after takeoff to ensure that fuel is transferring correctly. Transfer is indicated by transfer to left tank, transfer to right tank, and fuel transfer. The fuel in the wing tanks should also remain close to full. When the center tank is empty, select the center tank transfer to open for 2 minutes before selecting it to shut. The auxiliary tank not empty annunciators will remain on until transfer is complete. This must be by 1,600 kilograms, 3,500 pounds for each wing, but could occur at significantly different times. In extreme conditions, the fuel temperature in the right outer feed tank should be monitored to ensure that it remains within the limit of 3 degrees above the published freezing point of the fuel used. When JP5 is used, the minimum fuel temperature is minus 25 degrees Celsius. Post-flight. When the engines have been shut down, the boost pumps are selected off. If the APU is being used, the left inner pump will remain on. Fuel asymmetry, imbalance. Fuel imbalance up to 680 kilograms, 1,500 pounds, is permitted in flight. However, it would be sensible to take action before this figure is reached. If it occurs, the cross-feed and common feeds can be used to feed fuel from the heavy wing to the engines on the other side and restore balance. The cross-feed cannot be used to transfer fuel from wing to wing in flight. The first action is to open the cross-feed. The common feeds are then opened. Then the standby pumps are switched on. Finally, the boost pumps are switched off on the light side. The procedure is reversed when the fuel is balanced. Feed tank not filling. The worst situation which could occur is the isolation of a feed tank at low fuel states. If checklist action does not correct the problem, each feed tank contains sufficient fuel to permit either 23 minutes minimum continued operation at cruise power, or a descent from high level, an approach, go around, and a further approach. Is it likely that an inner feed tank would be isolated? The feed low level annunciator will come on if the level of either feed tank in a wing falls below full. The first action will be to put the left and right standby pumps on. This is to assist the inner boost pump in its operation of the jet pumps. The feed tank quantities are then checked to establish which tank has caused the warning. If the affected feed tank level does not rise, open the common feed. This permits both engines to be fed by the boost pump in an unaffected tank. If the affected feed tank is an outer feed tank, the outer boost pump can be turned off. In the unlikely event that the warning is caused by an inner feed tank, the outer feed tank will also be affected. The cross feed must now be opened to permit both engines to be fed from the other wing. Limitations. If auxiliary tanks are fitted, no fuel will enter the auxiliary tanks when gravity refueling. The quantity shown on each wing tank gauge will be reduced to 3,646 kilograms, 8,038 pounds. In flight, the asymmetry, imbalance of the fuel in the wings must not exceed 680 kilograms, 1,500 pounds. If the center tank fails to transfer fuel to one wing tank, 180 kilograms, 390 pounds of unusable fuel will be left in the center tank. When electrical power is reduced to the essential level, the boost pumps are lost. This results in the loss of the center tank transfer jet pumps, and therefore the remaining center tank fuel is unusable. Loss of the boost pumps also causes loss of the auxiliary tank transfer jet pump. In this case, however, transfer is by gravity feed until the final 95 kilograms, 209 pounds in each tank, which is unusable.